Hello, welcome to part number 4 for computer programming. This part should be actually much better than the previous one. Let me just make sure everything's good. Okay. Um, and the reason why is because I'm more awake now and I have coffee. And yeah, so I'm gonna go on watch page really quick. So in case somebody does end up chatting, I'll be able to do it. So I'll do the hi thing again, which should go on. Okay, there we go. All right, so with that said, I'm going to go ahead and get started here. So, some things to note is that from the previous time, I said that I was going to start at section 4 of chapter 3, and I looked through section 4 before I started streaming, and what I found out was that it is basically telling us the concept of overflow and underflow. What that basically means is that if you assign like a short integer to, let's say, a value called test var. So let me actually do this really quick so I can show you. So let's say do short and then I do test var. This is an example that is within the book as well. So if you're curious to know why I'm doing it like this, you'll be able to find more about it pretty soon here. So then the next part we're going to do is cout. We're going to do test var, and then we're going to end line as well. So end line. And then after that, what we're going to do is that we are going to do something like test var equals test var plus 1. Sorry. And then we'll do cout test var, and then we'll do end line, and then that's it. And then we're gonna actually do an additional one. I'm actually gonna break the spaces apart. It's funny. We're a bit before I started streaming. There was no cough sound, and as soon as I start streaming, it's like, hey, what's up? We're still here. You know, it's kind of funny. So we'll do test var again, and then we'll do end line, and then I'll go through these steps there. Okay. So basically, here is what's gonna happen. Is first I'm going to show you how the program actually works. So give me a moment as I do that. It's currently building the program up, so we just have to wait for that to be done. Okay, and that is done. Okay, so basically what it's showing you is this is what is called is overflow, and overflow means like you go beyond the limit of the data type that you used. In this case, we used a short integer, or I guess an integer. Yeah, um, short integer, which is basically the maximum amount of numbers you can put inside that is the 32,767. Now what the program did, as you could see here, so I assigned the value there, and then I outputted the value there, which shows on the first line. Okay, the second line is when I said, hey, test var is now test var plus 1. So whatever this number is, we added 1 to it, and then we outputted that, which gave us like the wrong value. This was supposed to be 32,768, but it is 32,768, but now it's minus or negative 32,768. And then right when we remove that one, it becomes the correct value once again. So this is a perfect example of overflow, which happens in the second line, and then underflow, which happens in the third line. Now underflow means that, let's say that the calculation is going on, and let's say that you had a long integer or a double. Well, actually, let's just do long integer, and you had that assigned to the number. Okay, now that would work fine, but if the calculation goes below that value, what's going to happen is that the you're going to get the wrong number. You will go into the negative sign. So then it would be like negative 900 million or whatever. Well, I think it's 9 million, but not 900 million. Anyways, which is the reason why you want to make sure to use the right data type whenever you are writing your code, because if the code deals with more than this much, then you want to use like a I believe a long integer or an integer, you know. So yeah. So with that said, we're gonna move on here, and we're going to go into the next step, which is or the next section, which is 3.5, which is typecasting. Now, the last time I wasn't able to comprehend what typecasting was, and I was like, I don't know what's happening, you know. Um, so what typecasting is, it basically allows you to perform manual data type conversion. What I mean by that is that you could assign like a data type to a specific value. I believe writing the code would be better than me trying to explain it. So give me a second, and then I'll use the code for explanation. Okay, so we're gonna go int books. Okay, so then we can also make a comment here. The book makes it to a books to read. Okay, so that's one. The next one is gonna be int months, and in this case, it'll say number of months spent reading. Okay, and then under the term, we'll do double per month, and then we'll do average number of books per month. Okay. All right. So after we have that, we're gonna do cout. How many books do you plan to read? Okay. And then we're gonna do cin, and then it's going to take in the books that the user entered, and then we're gonna do how many months will it take? Will it take? Sorry. Will it? Whoa. Wait. Will it or will it not? Will it take? Will it take? Will it take you to read them? Okay, there we go. Sorry, messing up already. And then we're gonna see in the months, which would be whatever the user specifies, and then it's gonna be per month equals. So this is where the static, what was it? What's the proper name for it? The typecasting comes in. Okay, so now you'll see now the stuff that we've done before, it's like something like books times months or books plus months, etc., etc., etc. But that's not what we're doing now. We are using typecasting, which is a bit different. Now typecasting is going to be static cast double books divided by months. And then it's going to go cout. That is per month books per month. And that's it. Now everything should work fine here, so let's just test this out. Okay, so let's say that I'm going to read 3 books, and it's going to take me 1 month. That's 3 books per month. Sorry, I should have probably made a better example. So let's say I'm going to read 20 books, and I'm going to finish them in 24 months. That's 0.33. So I don't even finish 1 book per month if I want to read 24 of them. Sorry, if I want to read 20 books within 24 months. So that's That's interesting. I'll actually explain this more in a moment here. I do need to actually take a small break here. I need to head to the bathroom. Man, I'm I'm doing such a poor job at doing these videos now that like the chances of somebody watching this is kind of crazy. So what I'm gonna do instead is I'm gonna leave you with some music here. I will be right back. You can listen to my awful music or my cool music. It depends on what you're into, right? So with that said, I will be right back. Um, yeah, yeah. I will be right back. So while that happens, you can watch the awesome changes that my computer is making while I'm away, and maybe even check the processors. There. Sorry, I'm just trying to. Okay. There. All right. Be right back. All right. Let me make sure everything is working fine before I start. Yeah, everything appears to be working fine. Cool. So I'm gonna go ahead and continue here. I'm gonna actually mute this for, well, not mute it, but just pause it. Okay, so let's continue on here. I know that the music was pretty good. At least it's pretty good for me. Anyways, go ahead and get started. Where was I? All right, understanding typecasting. So pretty much, what this example is pretty much doing is that the book says the variable books is an integer, but its value is converted to a double before the division takes place. Without the typecast expression in line 15, integer division would have been performed, resulting in an incorrect answer. I see. So basically, what we did there, or how we can change the data type on the fly, is that we could pretty much just change the data type by using the static cast command. I'll just call it command. Yeah, it is easier for me, and I hope it is easier for you as well. So let me make sure that the live stuff is working fine here. Yep, it's cool. All right, so that's kind of funny. So with that said, static cast double. So pretty much I changed the data type on the fly based on what I wanted to like do. Okay. So if I wanted to, what I could do is I could just remove the typecasting command here, and just make books like this, and then it's gonna give me like a different answer here. So let's do again, which was 20, 24, zero books, and that's incorrect. So as you can see now, once we add the static cast command, it'll be much better. So then the question becomes, what happens when we remove this and we remove this and we change the book to double instead of keeping it an integer? Okay. So once we do this, what's going to happen is, so let's say we do 20 again and 24, and we get the same, we get the good answer, see? Which is why it is important for you to actually the the proper data type whenever you're dealing with this. But just in the event that that is not the case, so let's say that somebody wants you to change the code. Well, what you could do is you could do static cast, and then you could do this. Sorry, my fault. Well, we do need this, but basically static cast. After we type static cast, we could actually open up and say we want this to be a double. So now books becomes double instead of an integer. So let's say that you are changing someone's code, and let's say that they want the value to do something different. So let's say that they want the value to actually um, have decimals and whatnot, and that's when you say, okay, so you want it to have decimals now instead of having an integer value. Okay, so I can change that. So then you go to the code, you look at what they want to change. In this case, they want the books to be a double value, and then after that, what they can do is they can I can just go into the code and be like, okay, so you want to change this, so then I can do this, and then I go back and then I look for books there. It highlights where the books are, and then I could say, okay, so now books is going to be static cast double. So I just changed the data type to for books to a double instead of an integer. I hope that makes more sense. I hope that made sense. I'm not sure if it did, but I tried. I understand it, so I'm just hoping that after my explanation, you understood it as well, which is why I like to explain stuff. Although I might not be doing a very good job at it, but I try. So I hope it helps somebody. So, with that said, Gonna move on here. Okay, so just to do like a mini review for chapter number 3, I'm just gonna go through this really quickly. Chapter 3 introduced the following things. Let me write it down here so you know. So what chapter 3 introduced was the cin command, in which you could do cout, hey, and then it also made it so that you do have to like assign a value before you actually do the stuff. So let's say that we do int a, okay, and then after that we do cout a, and then we do cin, and then we do a. Oh, sorry. There we go. See? So now we're getting the whatever the person whatever number the person enters, right? And then after that, what you could do is you could do cout. You entered. Oh, sorry. You entered, and then you do a space at the end, and then you do a, and then you do end line, and that's it. And then what this is gonna do is, like I said, which you can't do, see? Because a was assigned to an integer value. So you cannot do that, as you should have known that by now. It was just a test. Okay, I did mess up, but it was still a test. So like, let's just do this. See? You entered 232. So boom. So this is what we learned. And now we're gonna move on to, let's see here, what else, what other demonstration that they had here. Right, so we also learned the importance of the POW function for mathematics. Now, how I did it is I don't actually remember, so this will be kind of a review for me as well, in which I'll eventually get to the code. Okay, yes, so we also did something like this, in which like we had the code, and what we basically did was we used, so we had this area equals pi, which we already assigned. So we actually assigned a constant value to double, and then pi was to be equal to 3.14159. Okay, so now that we have this, what we also did was we did double area radius, and then we also did something like cout blah 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 blah. And then the important part that we did was we did cin, which was radius, so we got the radius. And then what we did was we assigned area to pi times pow, which is the reason why we had the cmat function there, or cmat library there. And then after that we took the radius that the user entered, and then we turned it to the power of 2. So basically what this did was, let's say that the radius that I used was, let's say, 5. Now that's going to be 5 to the 5 power, which will be 25. And then after it does this, then it multiplies it by the value of pi that we assigned on top here, which is 3.141. So then this basically equals to this 3.141591. So this is the equation. This entire thing equals to this. This is basically what it's saying. And we could also do this 5. So then, well, actually, sorry, this equals to that. There we go. So now if we made it 5, then it would be 5 times 5. Yeah. No, actually, it would be oh. So this is not actually 5. So the reason why it was 2 was because so this is to the second power, and then let's say that we change this to, let's say, 5. Sorry, 5. Oh, 5. this would turn into 5. So then 5 to the 5th power, pretty much. So we learned that. We learned the importance of the power function, which allows us to do stuff like this. So now we're gonna go back again. All right. Okay, that should be much better. All right, let's make a space here so that it's a bit more cleaner. And then the next thing we did was, I believe that's the overflow and the underflow stuff, which I didn't actually give. Well, I did give an example about it. I'm pretty sure I did, but I'm not entirely sure. So then we also learned that there is a thing called data type ranking, which is pretty much something like long double is first, double, and then double is next. I think to spell double here, and then float is next, and then unsigned long is next, and then long is next, and then unsigned int is next, and then int is next. Hello? So my computer crashed. I'm not even sure if this is live, so I'm gonna have to actually check that out really quick. Just give me a moment as I look into the stream here. Okay. It looks. Wait, what? I'm not editing anything. Looks like there's some issue going on here. I'm not sure how to tell if it's live or not, sadly. Just give me a moment as I look through this and make sure that it catches up to the stream here. Just give me a second. Actually, I'm not sure how I'm gonna test that, but it should be fine. Oh, okay. Okay, view on watch page. Yeah, it just keeps on repeating this over and over again. Let me verify that things work fine, and then we'll move on. But what I was basically working on in the last one, actually, if it's not working, then why should I? One sec. So while I try to fix this, just give me a moment. I'm just gonna go ahead and play a song for you. All right, so Daniel can't really check this out. So let me try to, okay, yep, it is definitely live now. Good, good. Okay, so now that this is done, we're gonna move on, and what we're gonna do is we're actually gonna work on what I was talking about earlier. I do apologize for that. What caused the issue was actually my amplifier slash DAC. Like it produced some type of an error which caused the entire stream to just crash. Well, the entire computer to actually crash. So with that said, so I was typing about data type ranking, which is this right here, and the data type ranking is something like this, which will be long double comes first, and then it's going to be double, and then it's going to be float, and then it's going to be unsigned float. I think the next one is going to be, sorry, float. I think the next one is going to be long, unsigned int, and then int. So these are the this is the ranking of the biggest to the smallest, I guess. So So with that said, we're gonna move on to the next chapter. So basically, section 3 deals with just the data type ranking. So that's, you should already know this on what you want to use, because before you even use it, when you're coding your program, you want to make sure that there is no overflows within the program. So choosing the right data type is the way to go, when it comes to numbers, especially, and letters too. So the next one is just what I talked about, which is underflow and overflow. We went through it, in which if the number is 36,767, was it? The 32,000, sorry, 606, 767. Sorry. And then if you add one to it, what will end up happening is that it'll go -3276. Sorry. Yeah, 768. So, and that's the short value, short int. So you want it to be, you never want it to go overflowing it, okay? So just be careful when you're using the data types. And then the latest thing that we learned was about static cast, which is right there, static cast, and then we can assign anything there. Like, if you want, we could even assign long in there, and then like just like whatever the word we want to change, whatever. Sorry. And then like if you're adding or subtracting or dividing or multiplying, well, multiplying, like everything can be done. I just made a comment. It's kind of funny. Oh, okay. So moving on, we are going to go into the next section, which in this case is going to be 3.6. I think we just did 3.5 then. Yes. Was it 3.5? Yep. Typecasting was section 5 of chapter 3. So with that said, the next one is multiple assignment and combined assignments, which pretty much means C++ allows you to assign a value to multiple variables at once. If a program has several variables such as A, B, C, and D, and such variable needs to be assigned to a value such as 12, the following statement may be constructed. So let's say that you want to assign a specific value to a lot of different words. So let's say that you want to assign 12 to a lot of different words. What you can do is you could do int a, so int bananas, apples, peaches, monkeys, islands, and then we can change that to 12. Sorry, you don't use int at the start of it. At least that's what the example says. Let me just verify this really quick. So listen to me. Quite often programs have assigned statements. I need to see a code example in order to understand this. What I'm going to do is I'm going to look for a code example here. Sorry, I did this wrong. What I can do is something like this. Let's say that I want to assign the integer value of bananas, oranges, peaches, and pineapples to 12. Now everything is gonna be 12, and I guess that's what it's trying to show me. Is basically is that I could do cout bananas, cout oranges, peaches, and pineapples. And then I can do end line at the end. Okay, so then this is what it's gonna do is it's gonna go 12, 12, 12, 12, 12. Sorry, 12, 12, 12, 12. Yeah. Uh, what? What happened? Runtime check failure. The variable oranges is being used without being initialized. Yeah. Thank you. So that came out wrong. I don't know what just meant wrong there. It should work fine. Like, I don't understand. What if I did this then? Int sorry, int E, then P, then I. And then I just change this to S, P, I. I don't understand what's happening. Oh, maybe Daniel is watching. Did he? I'll just copy and paste this instead of typing it again. Okay, so while Daniel looks in, maybe he'll look into that. I'm gonna move on, and I'm gonna do. Let me see here. The example that they used here is like a lot of numbers, and they're actually using it in a different way. Okay, this is actually good. I should probably write this program, so I will. Just give me a moment here. So this is gonna start. So I'm just gonna start writing here. In bag in sold. Sorry. And then we'll do store 1, store 2, store 3, and then we'll end it. Okay. So then we'll do cout 1 week ago. New widget stores opened. And we'll do this. We'll do at the same time to the same beginning. All right, I forgot to add this to it. Kind of messed that one up. There we go. Okay, so the next one is going to be and then the next one is going to be cin sold, and then we'll do store one. Ah, I keep on making this space. So okay, I'm going to continue writing. So basically it's going to follow the same pattern here, in which I'm going to do cin sold. I'm going to do store 3 sold. Sorry, sold. And then it's going to be cout the current inventory of each store, and then I'm going to do this. Then it's going to be okay, and I'm going to cout store 1. Wait, what? Oh, what? Oh, what? Oh, okay, sorry. Kind of messed that up. I keep on messing this up. And then I'm just gonna copy and paste this because I'm gonna write like just gonna change that number at the end there, which is gonna be just like store 2, store 3, store 2, store 2, store 3, and then it's gonna be done pretty much. There's a lot of spaces. Okay, so let's break down the program. So basically we have the integer values for beginning inventory, which is why this is written as beg inv, okay? And then we have sold, and then we have store 1, store 2, store 3. So all of these characters are using the integer data type, okay? So the next step is that what we do is we write the story. What is the beginning of the inventory, etc., etc. So then what we do is we do store 1 equals store 2 equals store 3 equals beginning in inventory. And then since we already have the sold integer data type, we store the values that the user enters inside store. Now that is the case, so we're basically trying to find out how many widgets has store 1 sold, and how we can do that is that we're using this command here, which basically means subtract from sold. But we haven't really assigned the value of let me actually see how this program works before I continue playing it. Something's wrong here, man. Something is not going right now. Something is breaking, and I don't know what and why. Because I written the code the same as it's written in the example, except I didn't add the comments there. And oh, that's why. That's why. I see why. Because at the end here, what I didn't do was I didn't see in the beginning inventory. So big in. So now it should function properly. 20. How many has 5, 4, 5, 2? Okay, so now the code actually works fine. That's because I didn't ask the user to specify the value for the beginning inventory, and that is the reason why it kept on erroring out. Um, so when we entered the value, so it's going to pretty much say, so basically every single store had 20 of one item. In this case, here, I'll just show it to you here. So that way it is easier to understand, I think. So each store had 20 of one item because that's what we assigned in the example, okay? And then the next step we did was store 1 is equals to store 3, store 3, sorry, store 1 is equals to store 2, store 2 is equals to store 3, and then in the end, it's going to all take away from the beginning inventory. Um, so each of these stores have the beginning value here, which we entered here, and in this case it is 20. So then what we did was we said, hey, how many of this stuff did store 1 sold? And then the person enters like the number, like in this case we entered, I believe, 4, and then it says, okay, so like subtract subtract the number that the user entered by 4, which pretty much meant that store 1 now has the subtraction of 4 there. So basically what ended up here is that 20 minus 4 happened pretty much. So then this one happened 20 minus 5. And then this one had 20 minus 2. So basically the stuff is the amount of stuff that the user enters here, and then this is already assigned here. Basically what we did here is that we said that store 1, store 2, and store 3 is equals to the value that the user entered over here. Okay, so yeah, so that's pretty much it. That is interesting. So the new stuff that we learned here is this one here, which is basically just saying, hey, this is how you can do this. And then we got this one here, which is this one. This is a new one. So this is something new we learned, and this is something new we learned. Well, actually, this is not new. This is the only new part, because we did do this on part 2, I think so. Um, so this is the latest one, line number 23. So, with that said, we're gonna move on. That's good to know, though. Is that we could just change that to the start. Um, all right, so we're gonna move on from section number. What section is this? Section number 6. We're gonna go to section number 7 here. See how object provides a way to format that data that is being okay. Let me just look into this to see if it's worth investigating. Okay, so section number 7 is pretty much this, in which it's just saying. So let's say that we assign a double value to A. Okay, let's do moon. Okay, okay. So double value moon equals 3 point there. Okay, so after that, what we do is that we already assigned them value to it, right? So we can do C out, left out, and then we can do um, and we could do set width to 3, and then we can do moon. Wait a minute. Set precision, I think it is. Isn't it set precision? What is the command then? I don't remember. It's supposed to be something like this. Just give me a second as I look through this really quick. Yeah, this should work fine, I think. Set W, yep, 5. And that's it. Set W is undefined, it says. So am I missing some type of a library or something? I don't think so. I have the IO stream there. Oh, I see. I am missing something. I'm missing this one here. Include IO man IP. That's what I'm missing. So now set width will be fine and it knows what it is. So let's do 3. So this, as you can see, this didn't change anything there. Like it's still the same. So what we can do is we can do set precision, I think, and then you just set precision. Okay, all right. So I'm not sure how what data type to actually use set precision yet, but what I do know is that set width works fine. So we can do set width to 10. And this is gonna display it a bit differently here. Now you can't really see it, so what we're going to do is we're going to do this. Oh, okay. So what we're going to do is we're going to do something like this to demonstrate the changes made here. And then we're gonna do this. Sorry. Whoa. And then we're gonna do end line. Okay, so now you'll get to see what it does. So then it actually created spaces there, as you could see. Now if we remove the set width command there, what it's gonna do is it's just gonna show that. See? So basically it's just adding additional spaces, or I guess maybe even subtracting it. I'm not sure if you can subtract it, but let me see. -10. What happens? Will the program break and say, what is happening? Okay, it basically ignores the entire number. But if you did, let's say 99, it's gonna put a lot of spaces there, as you can see. So that's pretty much it. It's just showing the set width command. All right, so set precision is what they're doing right after, which I wanted to actually focus on. I think I wrote it wrong probably. Yep, I did. So instead of doing set width, I should have done set precision instead of capitalizing the P. Now it actually works fine, see? So the language is case sensitive, so just be aware of that. Let me make sure that it's not 100%, and it is 100%. So what I'm gonna do is I'm gonna restore, and everything is back to normal. There you go. All right, so with that said, let me just double check to see my processor stuff to see if something's eating up a lot of memory. Everything appears to be fine, so I'm gonna go ahead and minimize this. Yep, everything appears to be fine so far. All right. Oh, what is this? What service? Oh, I don't really need that. I'm gonna get rid of it. Okay, all right. So moving on. So now that we use the set per precision command, I can show you how that works. So let's say that you want to show only 4 numbers right after. So what's gonna happen is it's actually just gonna show 3.29. This set precision command is great when you're dealing with money because you could say that you only want to show 3 of the numbers of the decimal um, numbers here. So basically you just show 3.229 instead of like showing something like for, let me actually make this even better, and let's say that this is money, and let's say that you want to show the entire value, then you don't even use this, right? But let's say that you want to create like a set precision stuff. So let's say 34.29. Okay. Now instead of doing 3, so if you did 3, he'll go 34.3. So it's gonna round up or round down. Okay. But you don't want that. You want the full money value. So then what it's gonna do is it's going to do $32.29. See? So this is a way to get more accuracy within the numbers when you're trying to deal with money. Okay, if you're not dealing with money, then you don't have to worry about this. But set precision is really good. So things that you need to remember is that if you want to use set precision, you need to have IOMAN IP library. If you don't have that, then it's not gonna work. So with that said, I'm gonna move on. Let's see here. So it's giving more examples of like how to use set per precision properly, but I have already showed you how it works fine, so there's really not much to discuss there. So I'm gonna move on here. What time is it actually? It's only 9. That's good. 9 something a.m. So the next step is, let's see here, the fixed manipulator. We're not gonna mess with that because we don't need to. Let me just read this really quick. Okay. So it's actually showing a fixed command here. In this case, it would be something like this. After set precision, we could do fixed, which would be then fixed and then moon. That is to make it so that it doesn't turn into scientific notation, because apparently when you're dealing with bigger numbers, especially when they're like linked with some decimal stuff. So if it's like something like 34,000.03, like it's gonna show up like a bit too crazy. So basically what we're trying to do is we're trying to not do that. So instead we're just gonna do 3. And what this is gonna do is it's gonna do 0.30. But we don't want 0.30, so we want 2. Now it's gonna do 2, which is right over there. See? So okay, so remember to add this, I guess, whenever you're dealing with money and using the set precision command. All right. So set with 8, day 1, day 2, day 3 total. All right. Let me actually just do this really quick. Okay, that works fine. Sorry, I'm just rereading more of the book stuff, so I'm just trying to um uh read more about it before I say something, so that way it makes more sense. So what's happening is I'm understanding the stuff first, and then I'm explaining it on what I understood to you, you know. So just give me a moment. So what it's doing is it's basically explaining more ways to use the set with command, like you could move this stuff to the left by just simply typing left. So like it'll be something like this, left, and then it'll go more to the left side, or if you want, you could do it to the right if you really wanted to, and then it'll move it to more of the right side, and you can manipulate that as well. So like it's basically just saying, hey, if you want to modify it even more, you have that option, you know. So okay. Okay. um so since so the commands that we can use with the set precision and set width stuff are actually these ones here. Set width equal, so n as the number, okay. And then the next one we can do is fixed, which we did discuss before. Show point causes the decimal and the trailing zones to be displayed even if there is no fractional part. And set precision, sorry, set precision number, and then left, and like I said, right. So the only one that it did not show was show point, which is pretty much like uh, like let's say that you have a value to something, like let's say that you assigned an integer value to like 12, right? basically what this would do is that show point would basically show the other value of it, but you want to make sure to make it precise, so you would do set precision as well, and then you would do 2, so that way it shows 12.00. So that's pretty much it. I have a feeling that I'm going to have to go to the bathroom again very soon. My stomach is acting strange. All right, so we're gonna move on from that, but remember, set precision is really important when you're dealing with money. So I highly recommend that you look into it more if you don't understand it, because that will come in handy quite a bit, especially if you're programming, because most people want programmers, but most people want them for, you know, some banking applications as well. So, and we all know banks pay quite a lot of money. So with that said, I'm gonna move on. Give me a moment as I check to see the chat. I don't have my chat on. Actually, I don't know how to check it right now either. Okay, there we go. Much better. Oh, my stomach. It's not good, man. Everything is falling apart for me. It's crazy. Working with characters and string objects. Although it is possible to use cin with the cin operator, which is this one here, to input strings, it can cause problems that you need to be aware of. When cin reads input, it passes over and ignores any leading white space characters, spaces, tabs, etc., etc. Once it comes to the first non-blank character, it starts reading, and it stops reading when it reads. Okay, so I'm just talking about stuff that you're probably like, stop reading from the book. So that's what I'm gonna start doing, is stop reading from the book. So this section introduces the getLine command, which will be something like, I'll just quote it here from the example: string name, string city. Since we're using string, we need to actually use the string library. So I will include that in there, string. Okay. So now it's actually gonna be like, oh, okay, so that's what you're talking about. See? Okay, so we add two strings to it, and then we do cout. Please enter your name. Oops. Making simple mistakes. getLine cin, sorry, name. And then we do cout. Enter the city you live in. And then we do cout hello. Name and line. Since I didn't add a quotation mark at the start, dude, I feel so sick right now, it's crazy. Cout you live in city and line. Okay. So what this is gonna do is it gets the line. Wait a minute. Yeah, I do need to take a break. Like, I really need to go AFK. I hope that the computer doesn't crash the next time I come back. But I'm gonna play the songs, so I will be back shortly here. And then we will discuss more about the getLine command. Okay. So with that said, I will be right back. Okay, I am back. I actually didn't get to go. I'm sure that you might have probably heard me ask the question. I only have one bathroom, so I can't really use it right now. So with that said, let's continue on here and discuss the get line command. So, wait a minute. Yes, I am missing something here. I'm missing get line, and I'm missing cin, and then we're going to do city this time. Okay, so that should work fine. So basically, the reason why we are using getLine, let me actually just read through this so that way I have an accurate description about it. Just give me a second. Notice that the username. It's funny. My professor used this example at the start of the class. He used the string library, he used the getLine stuff, and this is in chapter 3. Like, why? Why are we using? Why did he do that at the start? Like, I don't understand. Anyways, things to note is that the reason why we use the getLine command is so that our output is actually better. Man, bro, and then the city I live in is New York. Hello, man, bro. You live in New York. So let's just say that we don't want to do it like this, and let's just say we want to do cin, and then we want to do name. And then let's say that we don't want to do city like this. We do cin, and then we do city. Okay? So now that we have this, let's see what happens. We're going to do the same thing again. Man, bro. And that's it. So what happened? What caused this to go bad? Enter the city you live in. Hello, man. You live in bro. Okay, that's not bad. Yeah, sure. I live in bro. No problem. So, which is why I think that it's good for you to use getLine whenever you are dealing with spaces. Now, let's say that I didn't put a space there, so I put man and then I say New York. Now, this will work fine, but the reason why it messed up there was because of the fact that I added a space between man and bro. So now if I did, let's say, get line, and then I did cin, and then I did name. Okay, so now this will work fine because I'm gonna put man bro again. Sorry, and then let's do New York again. New York. Whoa, sorry. Hello, man, bro. You live in New York. That's because I didn't have to add any spaces there. Now, let's say that I do add a space there. So let's do man, bro, and then just do New York MA. Don't do ignore the MA, see? But if I did get line cin city, it's going to read that. So now let's do man, bro again. Let's do New York MA. Boom. See? So which is why it is better to actually use getLine cin instead of using cin. I'm not sure why they did then teach cin, but that's probably because to make the coding faster, so that way if you're dealing with no spaces, then you could do that. But if you're dealing with spaces, then you want to have getLine there. So that's cool. GetLine is a cool command to have. I like that. I like that a lot. You may also notice that since we use the string data type there, this pretty much means that we can assign characters to it. So we assign characters to names. So then we said, hey, enter your name, enter your city, etc., etc., and the user can enter these stuff by the string library. We can just add them in. So that's pretty cool. It's pretty cool. Like, let's say that you wanted to ask somebody about their name, location, and like stuff. You create a program, you create the graphic art and all that stuff, and then you say, hey man, where do you live, what do you do, blah 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 blah, and the user enters it, and like everything is stored within the computer. I'm not sure actually how to store all this stuff in an external file, but you could do that pretty easily. So you could actually create a survey just by doing this, you know, a simple code here. Boom, you know, done. You can see I've been drinking, I drank coffee and I'm drinking energy drink. I don't know, man. Anyways, we're gonna move on from this because it's not. Oh, it's actually adding some new stuff to it. Let's see here. Inputting a character using cin.get. As with string input, however, there are times when using cin to read character does not do what you want it to do. For example, blah blah blah, enter cin. Okay, so it's using get now. Let me read through this. Just give me a second. Yeah, allez, patron. It's kind of weird. So this is actually dealing with a get command, or was cin.get, which is pretty much. Let me see if I can. Let me just write this example down so that way you have. Well, actually, let's just add get and ignore. Okay, so let's do char ch int number. Sorry, number one. Number L. Sorry. Cout left. Enter in number. In number. Let's do C in ignore. Let's do cout enter a character. Could do ch equals cin.get. Out. Thank you. And that's it. So what this is gonna do is let's check the program out. So we enter 20. Oh, done. Notice that we didn't see out number at all, or we didn't see out ch, or I guess, yeah, ch at all. All we did was we got the number and then we did cin dot ignore, and then we got the we got the character and then we did cin dot get, and then that's it. Now we could also um, so 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 from the looks of it, this just displays the text outright. Like that's kind of crazy. But that's pretty cool that you can actually do that. This means that like if I wanted to, I could be like see out enter that number. Then I could do cin dot get, and then that's it. And it should display the number outright if I understand it correctly. Oh, it doesn't even like go through that. That's crazy. Wow. And what if I do cin dot ignore? What happens? Same thing, apparently. So then let's say that I do cin number. And then I do cout number, sorry, number. What happens? Oh, okay. Interesting. So if you don't want to like go down and create new text and like stuff, we could just do cin.get and that will work fine. And yeah, that's pretty awesome. That's pretty good. Um, I could think of some examples in which you could do that. Let's say that you have a game in which, well, actually, let's say that you are using some type of a cheat program in which it requires you to actually enter a specific amount of numbers. So the person that coded that program, that person probably used the cin.get command right after. So then it was like enter the amount of experience, and then it would be something like this, and then it's just gonna be like cin get. So let's say that you want to have like 9999999 experience. Boom, done. It's not gonna really like do some crazy stuff. It is right there, and you're done. But I'm sure that it's a bit more complicated than that, because what if you want to change it, right? But anyways, you get the gist of it, and it's that's very cool, very cool. So moving on. String state equals taxes in size, string member functions and operators. Okay, so nothing really crazy in the string member functions and operators. It's pretty basic. So whenever you want to use it, when you search for it, it'll be pretty easy for you. So don't worry about that. Um, moving on. More mathematical library functions. So it's pretty much showing me stuff like abs, like log, which I'm learning now in mathematics, sin, tan, and I think maybe even cos. Yeah, cos, f mod, etc., etc., etc. So when you want to use more mathematical stuff, you could do that because they have the options for you to do that. But I'm not going to go through this more because for coding, you're creating programs, not solving equations. But in a lot of I think in a lot of banking applications and well actually I think if you're coding for something, especially if it's a complex program, at some point you're going to have to use mathematics, and that's when the mathematical functions come in, because C++ has quite a lot of them. It has, let me just read through them really quick. It has ABS, cos, exp, fmod, log, log10, sin, square root, and tan. It doesn't have ln from the looks of it, but that's okay. Ah, it's actually dealing with random numbers. That's something that my professor loves to use. Random numbers are useful for lots of different programming tasks. The following are just a few examples. Best part was that when we were assigned to do random numbers, like he gave that to us, I believe, on week 2. When on week 2 we were supposed to cover chapter 2. So I don't know. Anyways, moving on. Wonder how long has it been since I've been streaming? Okay, almost 2 hours now, huh? It's already 10. Crazy. All right. So, moving on. Let me just read through this really quick. So we're actually going to use the CST-lib here. Include CST-lib. Yeah, that's it, right? Oh, I'm actually using the wrong one. CSTD. CST. There we go. That's much better. Okay. Let me look through some programs. Let's add C time as well in there then. Okay. Right, so there is no space in between. That's the reason why that was bad. Pretty much the same thing for die 2. Yep, same thing. Yep, definitely the same thing. Okay, next up is cout die 1. And cout die 2. Okay, so this program should work fine. Let's check it out. 2 and 6. 6 and 4. 1, 1, as you can see. So basically how the program how the program works is that we assign an constant, which is pretty much that the number should not be changing from 1 to the maximum value of 6. Okay, and then we assigned integers to the words die 1 and die 2. And then the next thing we did was we used an unsigned seed. Now, what is seed, you might be wondering? I am wondering as well, so we shall look it up really quick here. A second. Okay. All right, so the class is deprecated seed random. Okay. There's an easier way to actually do this. So this is using a for loop. We haven't really gone to that point yet, so we're gonna wait. But this is a for loop right here. Okay, so moving on. What the hell is seed then? That's what I want to know. What is seed? Is it gonna give me the same page? Yeah, it's gonna give me the same page. Trying to find seed. That should be it. Okay, stores a vector of unsigned integer values that can supply a randomized seed for a random number engine. Okay, so type def unsigned int result underscore type blah 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 sequence. Okay, so srand is a function to do the randomization of seed. Unsigned seed is, I guess, the unsigned integer, which is once again bigger than integer. So and it only deals with positives than negatives. So after that we did time 0. I'm not sure what this time 0 means. Like, it's not really. Not really explaining much of this, but that's alright, I guess. So die 1 brand, I don't know how to explain this properly, to be honest. But I can skip through the, I guess, the technical details and go down. So it's gonna say rolling dice, and then die 1. It's what die 1 is going to do is that it's going to use the rand function. It's going to, I think this is multiply. Operator. Okay, so these are operators. Okay, creates the value of expression in macro argument as text. Okay, I don't know what that means. All right, moving on. Min value minus max value minus min value plus 1. So it subtracts 1 from 6, and then it adds 1. And then it adds 1 again. So that's how it randomizes it. So then each time you use the program, it's going to do the same thing here. 4, 6, 4, 5, 1, 5, 5, etc., etc., etc. So that's how you do the randomization of the stuff. All right. Moving forward. Section 10. Focus on debugging hand tracing a program. This program asks for 3 numbers, then displays the average of the numbers. Okay. Easy to do. So basically it's something like this. Double 2 equals, sorry, double number 1 equals 30.2. Number 2 equals 20.3. And number 3 equals 93.29. Okay, so after we do that, then what we do is that we do average, and then we do number 1 plus number 2 plus number 3 divide by 3 equals, okay, well actually for some reason it's not really taking the average. That is because we haven't defined average there, see? So then we need to do one more, and we need to do AVG. Now we have AVG there, so now we can do cout, left out, AVG, and 9, and that's it. So now it's going to give us the answer, which is this. Woohoo! Now, since the answer is like that, what we can do is, if you remember our previous section, we need to make sure we have IOMAN IP there. And what we can do is we could do set precision to 2. And what that's going to do is it's going to give us 82. Or if you wanted more, we could do 4 and we can get 82.6 or 5 in this case, I guess. Come on, give me at least 4. Whoa, what happened there? Oh, okay, so it actually rounded the 0 to actually nothing. So this is actually 81.60. Since there's nothing there, we have to assume that it's 0. Because if I remove this, what's going to happen is that it is going to display that. So it rounded up. So there you go. All right, done with that. So you could basically use this as your calculator as well. So this is pretty much showing how to use a chart for section number 11, as in how to use a, what's that thing called? I can't remember the name of it. Give me a second here. Hierarchy chart. Yes, yes. That's what is showing. What's showing there is how to write that and how to write the pseudocode. So it's basically giving these steps on how to write a program efficiently. How you should write it is you should do pseudocode first, and then do the hierarchy chart, and then well actually pseudocode first and then write the code, and then do the hierarchy chart to explain what the code does, and then that's it. What that's going to do is just going to make it so that your program makes sense, you know, or it makes logical sense to the person that is reading the code. Okay, so chapter 3 is done. Fantastic. There's quite a lot of sections to cover here from the looks of it. Review is pretty intense there. But I'm not going to do that right now. My brain cannot handle it. Relational operators, okay. Yep, greater than, yep. This is where we might be learning while commands and for loops. Oh, we're learning the if right now here, actually. So the commands that we're about to learn. So we're on chapter 4 now. So we learned quite a bit in chapter 3. We learned the cin. We learned these. We learned the cin commands. We learned the cin.get command. We learned getLine, cin, whatever else, like something. Okay. We learned the pow command, bananas to the 3.0 power. We learned the static cast command, in which we do this double super. Okay. And then like +1 or plus whatever. And then we did the, and then we learned, what else did we learn? The near chapters, we also learned the sran command, or I guess ran command as well, which basically means random. We already know about the constants, right? The constant volume, constant int volume equals 2, 3, 5, okay. 2, okay. We also learned, let me go through this really quick. All right, we also learned the set precision stuff. Set precision to 2, or set width to 2, or and then we also learned left, right, show point. Okay. So we learned quite a bit in that section. We didn't actually go super deep into sran, which was kind of bad, but what are you gonna do, right? Let's see. Let me go through it really quick. Yep. Okay. So I think I covered most of the stuff that that chapter 3 covered. So that's pretty much it. So we learned all of this and how to use it properly. All right, we also learned the hierarchy chart, which was double, etc., long double, blah, blah, blah. Okay, so now we are going into the if statements. So it's something like this: if expression, if something happens, then statement. So I already know this because I've been doing this for a while now, but I will write an example soon. But before that, I'm going to take a small break here, so I guess it's a good time to actually stop part 4 at the end of chapter 3. I hope that this was a learning experience for you, it was for me. I learned some new tricks and some new interesting stuff, I guess. Kind of. I don't know. To be honest with you, I'm kind of losing interest in coding for some reason. It's not that fun. Anyways, let's move on. So with that said, thank you for watching. I do apologize for being a bit worse at doing this properly and making it entertaining or useful. As you could see, the only person that watched was for 33 seconds and then the person stopped, which is to be expected, I guess. Um, so with that said, thank you and have a good day. Take care and goodbye.